Very good morning, everyone. Very good morning, everyone. This side, Professor Heena Saxena, Assistant Professor, SIRTE MBA. Here, I'm going to record on a video lecture on quantitative methods on the topic dispersion. For the first, we'll discuss about what is dispersion. Dispersion refers to the variation of the items among themselves and around an average. Greater the variation among the different items of a series, the more will be the dispersion. As per Wallace, dispersion is a method of variation of the items. Is also we can consider as scatteredness of the item. It shows the degree of scatteredness, how much the data is dispersed from the mean point. Okay. Then we will looking forward of the objective of measuring our dispersion to determine the reliability of an average to compare the variability of two or more series for facilitating the use of other statistical measures basis of statistical quality control. These are the objective of measuring dispersion. Now we are looking forward for finding a properties of a good measure of dispersion. These questions mostly asked in a main exam also. What are the good properties of measured dispersions? First is easy to understand, simple to calculate, uniquely defined, based on all the observation, not affected by the extremes observation, capable of further algebraic treatment. Now, further moving forward, we'll discuss about the measure of dispersion. It's mostly asked in the question also, what is the difference between absolute and relative measure of dispersions? So now here is a look on absolute and relative measures discussion. What is absolute measure of dispersions? Absolute measure of dispersion expressed in the same unit in which the data is expressed. Example, rupees, kilometers, liters, kilogram, etc. Likewise, which we have a same kind of units which we can express in terms of units that are in absolute forms. Okay, that's why we had called them a absolute measure of dispersions. Now we will talking about the relative measures of dispersion in the form of ratios or percentage. So is independent of units that are not dependent on the units, that are independent from the units, are known as relative measure of dispersions. Here it is also known as coefficient of dispersions. Likewise, example, we can talk about the fractional wise, the percentage wise data, the percentage wise unit. We can talk about the relative measure of dispersions. Now look, moving further, we can here are the following methods for measuring a dispersions. First is range, second is range and quartile deviations, third is mean deviations, fourth is standard deviations, fifth is coefficient of variations, and fifth is Lorentz curve. Now we will discuss about what is all about range. It is the simplest measure of dispersion. It is defined as the difference between the largest and the smallest value in the series. See, we have a three series in our quantitative methods, that is individual, discrete, and a continuous series. In individual series, you have to find out the largest number and the smallest number. You have to subtract it. Then you get the range of a series. So here is a formula for finding a series is range equals to largest minus smallest value. Here, L is also denoted, already defined as largest value and the smallest value. And you also find a relative measure of dispersion of range also. So you have to find a coefficient of range, that is largest minus smallest, and upon largest plus smallest value. Now looking forward, here is some practical questions related to all the threes, individual, discrete, and a continuous series. You have to find out a range of a given series. Here I disclosed answer also, so it might be helpful for you to get the answer as per this question. Then moving forward, now we have discussed about what are the merits and demerits of a range. Merits of a range is simple to understand, easy to calculate, widely used in statistical quality control. And the demerits of range is cannot be calculated in open-ended distribution. We required a ended distribution because we have to find it a largest or a smallest value for finding a range, not based on all the observations affected by sampling fluctuation. Any kind of fluctuation is in a variable or in a data set. There's a fluctuation in range affected by the extremes value. Then now we will discuss about the most important topic. interquartile range and quartile deviations. Firstly, we will look forward to the interquartile range. What do you mean by interquartile range? Interquartile range is the difference between the upper quartile and the lower quartile. It covers dispersion of middle 50% of the item of the series. Symbolically, interquartile range that is denoted by the upper quartile is Q3 and the lower quartile is Q1. The difference between the Q3 and the Q1, you get the interquartile range, that is IQR. IQR equals to Q3 minus Q1, right? So so now looking forward with the quartile deviation. What do you mean by quartile deviation? Quartile deviation is the half of the interquartile range, is also known as semi-interquartile range. Previously or in upper lines, we had discussed about the interquartile range. It is a semi-interquartile range which is divided by 2. Then we are finding an interquartile range Q3 minus Q1, and if we divide it by 2, we get a semi-interquartile range or the quartile deviations. Now you have to find a relative measure of quartile deviation, that is also known as coefficient of quartile deviations. It is a relative measure of quartile deviations. Then the coefficient of quartile deviation is Q3 minus Q1 upon Q3 plus Q1. Here are some practical questions of interquartile range and quartile deviation in all the series, like individual, discrete, and continuous series. So in this also you have to find out the value of Q3, Q1. Then further on, you have to get the answer of Q3 minus Q1. Okay, and in class also, I had just discussed about how you have to find a value of Q3 upper quartile and a lower quartile by using a split method of dispersion and individual series. And Q3 you have a formula of Q3 and Q1, and discrete series is like n plus 1 divided by 4 and thrice of n plus 1 divided by 4 for Q3. Then you have to find out the value of Q3 minus Q1. In continuous series, you have to find out like n by 4 for the Q1 and 3n by 4 by the Q3, right? And here n, capital N, represent a total number of frequency, right? Total number of frequency. That means sum of all the frequency is denoted by capital N. Already discussed in the class. So you people have to discuss or solve this question and submit me as an assignment. Then looking forward, that's all for quartile, interquartile range. That's all. Thank you so much.